Hi guys, welcome to the session. Today we are going to discuss about machine language. So there are two levels in programming language, low level, high level. There are two types in low level, machine language and assembly language. So what is machine language? It's a language in which is written in zeros and ones. So what assembly language? Assembly language is a language which is represented in the form of symbols and some human readable commands like add, subtract, move. Now what is high level language? It's a language which is very close to humans, means it is in human readable format. Let's see how does this look like. If you see here, line number 18, we are saying print welcome to Strivv. So this is called as high level language. If a normal person who is beginner to coding sees this line, he can understand that we are saying print welcome to Strivv to the computer. So it's very close to humans. It is in human readable format. Now let's see how does machine code looks like. This is how the machine language looks like. If a normal person sees this, he will understand nothing. The person who is only expert in machine language can understand these ones and zeros. What does this ones and zeros means? Now let's see how does assembly language looks like. So this is how the assembly language looks like. It consists of symbols like percentage, hashtags, and commands like subtract, move, add. So this is the assembly language for printing welcome to Strivv. So this is how it looks like. Going back to our question, what is machine language? So it's a language in which series of tasks or set of instructions or program is written in binary form. Binary form means it's a type of numbering system which consists of only zeros and ones. It is fundamental language of the computer. Fundamental language means it is the only language computer can understand. Computer cannot understand high level language, computer cannot understand assembly language, computer can only understand machine language. Computer can only understand zeros and ones. Now you may get a doubt that why computer only understands zeros and ones. There is a reason for that. So if you open up the computer, there will be a motherboard. In that there will be a main component called CPU, Central Processing Unit. What does the CPU is made up of? It is made up of millions of transistors. So what are these transistors do? So if you see here, there is a transistor. What does this transistor do? This transistor just acts as a switch. Whenever if you pass high voltage to this transistor, it allows the flows of electrons. Whenever you pass low voltage to this transistor, low voltage means zero, it restricts the flow of electrons. If you don't know what is a transistor, assume or imagine the transistor as this switch. What does this switch do? When you switch on the fan, it allows the flow of electricity or flow of electrons into the fan, and the fan starts rotating. When you switch off the fan, it restricts the flow of electrons and there will be no flow of electricity through the fan and the fan stops rotating. Now let's create a simple computer using one transistor. So this is how our computer looks like. Consider a bulb, a light bulb connected to one transistor. I claim that we can represent information using this circuit or this computer. So right now we are representing 0. 0 means we are not representing any information. 0 means nothing. But if I simply switch on the light, we represent 1. To represent 2, we need to have another bulb, another transistor. Unfortunately, right now our circuit can only represent two values, 0 and 1. So let's add another transistor. We are gonna add transistor 2. Now we have two transistors. To represent 2, what we need to do is we need to switch on bulb 1 and we need to switch off bulb 2. 2 is represented as 1 0 in binary. Now to represent 3, we need to switch on both the bulbs. 1 1 is represented as 3. Now we are representing 4 values. Using two transistors, we can represent 4 values. If you want to represent 0, we will switch off both transistors, 0 0. If you want to represent 1, we will switch on second transistor. For 2, we will switch off second and switch on 1 0. For 3, 1 1. So if you want 4, it's obvious that we need to add another transistor and another bulb. Let's do that. Now 4 is represented as 1 0 0. To represent 5, we will switch on the third bulb. 1 0 1 is represented as 5. 1 1 to represent 6, we switch on the second bulb and the first bulb. 1 1 0. To represent 7, we will switch on all the bulbs. Now how many values we can represent? There are 3 transistors, so the values we can represent it is 2 to the power of 3. 2 into 2 into 2. 2 2s are 4, 4 2s are 8. We can represent up to 8 values. If you can see here, for a 3-digit number, we can represent up to 8 values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 7. For the number 8, we need to have 4 transistors. Like that. The number of transistors increases, the number of values we can represent will also increase. Technically, we don't call these as transistors. We call these as bits. So the number of digits increases, the number of bits increases. For example, if we have only 1-digit binary number, we call it as 1 bit. If we have 2-digit binary number, we call it as 2 bit. If we have 3-digit binary number, we call it as 3 bit. Now our computers, mostly our computers and laptops are 64 bit. Okay. Now what's the logic behind the converting binary to decimal or decimal to binary? Let's find that. Let's open a text editor for that. If we go back to schools, we'll remember there will be a concept called units place, tens place, hundreds place, thousands place, right? Thousands place, hundreds place, tens place, units place means 1. If you write a number like 1789, we will divide it like this: 1000 plus 700 plus 80 plus 9. 9 is units place, 80 is tens place, 700 is hundreds place, 1000 is thousands place, right? In a similar way, we will represent a binary number. For example, if we take a binary number 1101, we represent it in the form of 2 to the power of columns. Like here we are representing powers of 10, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. In a similar way, in binary we use powers of 2 as columns. 2 to the power of 3, 8, 2 to the power of 2, 2 to the power of 2 will be 4, 2 to the power of 1 will be 2, 2 to the power of 0 will be 1. So if I represent 1, 0, 1, as I said in the starting, if it is 0, it will represent nothing. it is not representing any information. So wherever there is 0, you will not count that bit. Wherever there is 1, you will consider that bit. For example, in 8-bit, here at the 8th place we'll have 1, so we'll consider 8. In 4th place we have 1, so we'll consider 4. In 2th place we have 0, so we don't consider it. In 1st place we have 1, so the answer is 8 plus 4, 12, 13. Let's see whether it's right or wrong. So 13 is represented as 1101. So this is how the conversation takes place. If the number is big like this, we will take more number of columns like 128, 64, 32, 16, 8, 4, 2, 1. And we similarly, in a similar way, we can find out which decimal number it is representing. Now, how does we convert decimal to binary? For example, if you take the same 13 number, we need to divide it by 2. So 13 by 2 gives us quotient as 6. 2 6 are 12. 2 into 6 12, and the remainder will be 1. And the 6 will come down, 6 by 2. 6 by 2, and 2 3s are 6. Quotient will be 3 and the remainder will be 0. 6 minus 6 will be 0. Again 3 will come down. Again 2 1s are 2. Quotient will be 1 and the remainder will be 1. 3 minus 2 will give us 1. 1 will come down and 1 divided by 2. 2 zeros are 0. Quotient will be 0 and the remainder will be 1. So 13 is represented in binary as 1 1 0 1. We need to come from the bottom to top, not from top to bottom. Okay, so this is how you convert decimal to binary number. Now you may get a doubt that, so how does we represent characters? We deal with characters, like for sending email you need to type characters, for searching in Google you need to type characters. Wherever you mostly face characters. So how does these characters get converted to binary? So for these there is an character encoding called ASCII, American Standard Code for Information Interchange. What does this do is, it applies globally. Globally, A is represented as the decimal 65. So whenever I want to print A, I will say 65 to the computer, and the 65 will be converted to binary. We can convert decimal to binary as we have seen before. If I say B, it will be represented as ASCII 66. So decimal 66. So what does this ASCII do is, it links our characters to a decimal number. So this is how we represent characters in binary. So now we are able to represent characters and numbers, so we can send mails, we can receive mails, we can search in Google, we can search in YouTube. So what is a bit? Previously I have said 1 bit, 2 bit, 3 bit. So what is a bit? A bit is a computer term for data storage. For example, if you take liquids, in liquids we represent storage in the form of milliliters, liters. If you take this jar, what is the data storage of this jar? 20 milliliters. In the same way, if you take solids, we represent in the form of grams, milligrams, kgs. Like that, in computer we represent data storage in the form of bits. 1 bit, 1 MB, 1 KB, 1 GB, 1 TB, like this. A bit is a computer term for data storage. So for 1 bit, as we have seen, we can store up to 2 values, zeros and ones. For 2 bits we can store 4 values. Like that, for n bits we can store 2 to the power of n values. For 4 bits 2 to the power of 4 16. For 5 bits 2 to the power of 5 32. 32 values we can store. 32 information we can store. 32 types of information we can store. So using these characters we can represent images, we can represent videos. Every image in our computer or video is stored in the form of binary, in zeros and ones. Those zeros and ones, if you take image, represent the location of the pixels and the color or wavelength of that particular pixel. For example, here blue color is present. So all this data will be stored in the form of zeros and ones. Those zeros and ones will represent this location. Like the center location will be in blue color in rectangle shape. All those zeros and ones will represent the location and the wavelength of that pixel. So every video, every text file, everything will be stored in computer in the form of binary. Where does computer store data? So there are two data storages in computer. One is temporary data storage, another is permanent data storage. The left side one is the temporary data storage called RAM. Here we store temporary files like cake files or recent files. For example, if you open like 10 tabs in Chrome and if you close the Chrome directly, they will be saved in cake memory. Again, when you restart the computer, Chrome will ask you whether you want to restore those tabs or not. So all those files are stored in this temporary storage called RAM, read access memory. So permanent data will be stored in HDD, hard disk drive or SSD. So permanent data storage means like images, screenshots, videos, text files. All these things will be stored in these HDD and SSD. Now, how does communication happen? Computer doesn't know assembly language, computer doesn't know high level language. Computer only knows machine language, but we know high level language. How does this communication takes place? We need to say commands to the computer so that we get the output, right? So how does this communication happens? So there will be a translator. So what is the job of this translator is to translate whatever I say in high level language into machine language. So these are the types of translator. Assembler, what does assembler does it converts assembly language into machine language. So compiler and interpreter converts high level language into machine language. Though they work differently, I will explain them in detail later. For example, let's open text editor. For example, imagine that I went to Japan and I met a person A. I need to talk with him, but I don't know Japanese, I only know English. So what would I do is I will keep a translator with me. What does he do is whatever I say, he will convert it into Japanese. For example, if I say what does this translator do is he convert it into nani. In Japanese we call this as nani. For example, if I say thanks, he convert it into arigato. If I say good morning, he will convert it into ohayo gozaimasu. So this is how the translator works. Okay. Now, why can't we code directly in machine language? Why we need to write in high level language, then we need a translator to convert it to machine language? Why not we code directly in machine language? Previously, we used to code in machine language. The first language introduced was machine language, but there were problems with machine language. For example, machine language is dependent on the machine. For example, if you take a 32-bit computer and write a machine code for that. It will not work in 64-bit computer. Let's go back to the previous example to understand this more. For example, if I want to specify, this is a 3-bit computer. Right now we are having 3-bit computer. If I want to specify 1, what would I do? I'll switch on this. So this is a 3-bit computer, but what I have is 2-bit computer. If you give me this code 001, if I execute the same code in 2-bit computer, we will not have this one. So we will not have this one. Now if I give a code 001, what does my 2-bit computer can do? It cannot do anything, right? So it changes from machine to machine. For 2-bit computer we need to specify 0, 1. For 1-bit computer we need to specify only 1. So it changes from machine to machine. This is the main drawback of the machine code. And also it is very difficult to debugging the code. If there is an error in this code, it will be very difficult to debug because everything is similar and you can't find the error. For example, if there is an error in this code, we can easily find out. This is a high level language, and if there is an error in this code, we can easily trace that out. Syntax error, it will be displayed line 84. Okay, so these are the main drawbacks of the machine code. Because of these drawbacks, assembly code was invented, and in assembly code also there are some drawbacks. Because of that, high level language was invented, and right now we are using high level languages. So thanks for watching. Let's meet at another video. Goodbye.